behalf of Aluminium Casters Association India, as well as from Center for Study of Science, Technology and Policy, well known to all of us as CSTEP. A warm welcome to all the participants for this webinar on decarbonization and improving energy efficiency in India's MSME manufacturing sector and the die casting industry. Energy efficiency is one of the major concerns that we all have. Similarly, cost savings, because energy also consumes cost. So cost savings is also a major concern, a major challenge for all of us in today's times, especially when the cost of raw material as well as the cost of energy is going up. So this is a major concern for all of us, and that is why CSTEP, the Center for Study of Science, Technology and Policy, in association with Aluminium Casters Association India, is aiming to conduct a study in the aluminium casting sector in India. And the aim of the study is to analyze the energy consumption of the MSME units in the die casting fraternity and find the feasibility of decarbonization technologies as to how they can be used, not only to reduce emissions, but also to help save energy and costs for the MSME units in the die casting fraternity. This webinar that we have organized today is the first step in our CSTEP ALUCAST Energy Audit project. And the focus of this webinar would be to create an awareness about this initiative in which CSTEP and ALUCAST have together joined hands. And we want as many MSME units in India to participate in this project so that we are able to implement the decarbonization technologies, and at the same time, we are able to improve the energy efficiency of our industrial units in the country. So this is how we plan to go about in today's webinar. There would be a brief introduction of CSTEP, as well as a brief introduction of the ALUCAST CSTEP Initiative. Then what are the objectives of this initiative, this energy audit project? What outcomes we would expect from this project, and a few case studies on decarbonization and energy efficiency improvement project would be also discussed by the speakers with us in today's webinar. We are very happy, and I take this privilege to introduce the speakers for today's webinar. Mr. Dhruv, Senior Research Analyst at CSTEP, a mechanical engineering graduate with Masters in Sustainable Energy Technology from the Delft University of Technology, Netherlands. Mr. Dhruv is working on multiple projects in the field of industrial energy systems, rooftop solar PV, hydrogen systems, etc. A very warm welcome, Mr. Rajiv. Our second speaker for today's webinar would be Mr. Rakesh Yecho, Project Director for this ALUCAST CSTEP Energy Audit Initiative. Mr. Rakesh is an electrical engineering graduate with Masters in Business Administration. He is a BEE certified energy auditor cum energy manager. And as a team leader, he has handled more than 750 number of detailed energy audits and related studies covering Indian and international client base with a diverse segment of industries, including designated consumers and other industries. He has been the lead consultant for several national as well as state level projects. A very, very warm welcome, Mr. Rakesh, on behalf of Aluminium Casters Association India, and a very warm welcome once again, all the participants, all the representatives of the die casting industry who were associated with ALUCAST for this webinar. And I wish all of you a very, very happy interaction and a very happy learning through this webinar. Thank you so much. And now may I invite Mr. Rajiv to take over.
Yeah, hang on, I'll just share the screen. Okay, so good afternoon, everyone. Before we start the presentation, I just want to take a moment to thank the ALUCAST team, the entire ALUCAST team, for all their efforts and their cooperation so far in helping plan this event and the future steps. Here at CSTEP, we're very grateful for that. So good afternoon, everyone. My name is Dhruv. I'm a senior research analyst at CSTEP. And today we want to talk to you about one of our upcoming projects called a study on the decarbonization in MSME manufacturing sectors in India. And we are the objective of this presentation is for us to talk to you about this more so that interested MSME units in the aluminium die casting sector can be a part of this study. So to begin with, what is CSTEP? So CSTEP, or Center for Study of Science, Technology and Policy, we are a not-for-profit research organization. We are based in Bangalore and Delhi. Primarily, our work is about conducting research and analysis and using these to provide solutions to policymakers. We work in multiple fields, such as the climate and environment sector, the energy sector, the air pollution, artificial intelligence, and such multiple fields. We have worked previously on several projects such as clean air action plans for various cities in North India, mapping the solar potential, the rooftop solar potential for cities such as Bangalore, and now we're expanding into other cities. So these are projects that we as an organization have worked on, and we have done this through our cooperation, through our partnerships with various government and research agencies. Some of our key partners include the Bureau of Energy Efficiency, BE, Niti Aayog, MNRE, which is the Ministry of Renewable Energy, the Department of Science and Technology, MOEFCC, as well as research or academic institutions like IASC, Indian Institute of Science, or IITs. So within CSTEP, we have an energy and power team, which focuses on the entire spectrum of the energy and practically the electricity sector in India. This covers the entire regulatory environment, the transmission and distribution systems, and our team, which consists of the renewable energy and energy efficiency team. We primarily focus on such projects focusing on the production of energy, clean energy, and how energy can be saved. We have worked on similar projects within this industrial energy sector. We have worked previously during the early conceptualization of the PAT scheme for the larger industrial players and how their coverage can be deepened. We have looked at energy efficiency studies, modeling in the cement sector, in the iron and steel sector, as well as some studies into waste heat recovery in industries in Karnataka. So that all this is the work we've done previously, but this time we wanted to focus on a different aspect of the energy system in India, which is MSMEs. Now, why MSMEs? For us, there were two very important aspects we see here. One is for the MSMEs themselves. If you look at the national context, industries and MSMEs, this is a huge consumer of energy. It's a huge consumer of fossil fuels. We estimate that MSMEs themselves contribute about 25% of India's industrial energy consumption today. So this is a big number, which will only keep rising in the coming decades as India industrializes even further and our economy grows. So we cannot ignore the energy consumption of MSMEs. And what is key to understand here is that 85% of this energy demand that we see is being met through fossil fuels, like furnace oil, natural gas, LPG, diesel. Even the electricity in most states is predominantly being produced from fossil fuel heavy power plants. So there is indirectly and directly there is a lot of fossil fuel use in MSMEs, which contributes also to a lot of emissions that needs to be looked at sooner or later. Now, while I've spoken about the national context, the second key thing that we've seen is for the MSME units itself, this energy cost is a significant part of the product manufacturing cost. We have seen this not just with the aluminium casting sector, but we've also seen this with pharmaceuticals, with textiles, with chemicals. We've seen estimates of maybe even up to 30–40% of your entire product manufacturing cost, depending solely on how much energy you use. Now, I don't need to remind anyone about how now, especially in a post-COVID world, the financial challenges most parts of the economy are facing, especially the MSMEs. There are a lot of constraints which have come in now. And if you see in recent months how fuel costs are rising across the world and now in India, we are seeing how fuel availability itself are issues. There are supply chain issues with procuring your fuels. These are big problems that MSME units such as yourselves have to deal with on a day-to-day basis. For the country itself, India, as you all know, has a pledge to create a net zero economy by 2070. So to decarbonize the entire economy we have today within the next 50 years, this is a very, this requires a lot of effort from our policymakers, from our industries. This will take a lot of investment, and while this is good for the environment, we cannot underestimate the amount of effort and investment required here. And MSMEs must be a part of the solution as we move forward. So these are the two twin challenges that we were seeing within the industrial sector. And what we came to understand, came to believe, is how we need to look at alternatives to fossil fuels. There needs to be a focus on a decarbonization of the MSME sector, by which I mean reducing the fossil fuel consumption in an MSME unit without actually decreasing the productivity of the unit itself. How these decarbonization technologies, they can play a role in combating both issues and creating benefits for both MSME units and the country itself. What these decarbonization technologies are, I'll come to it in the next slide. But it's vital that we explore their feasibility and we start talking about how they can be implemented in MSMEs now. So this is the focus that CSTEP has seen, and we are conducting a scoping research project here to determine the technical and economic feasibility of implementing such kind of decarbonization technologies in a group of MSME manufacturing units within the country. Now, what does this mean? How are we going to do this? So the first thing we looked at were carbon-intensive sectors within India, sectors which consume a lot of energy, which have a lot of carbon emissions, and are not necessarily looked at by the government or by other researchers itself. They do not necessarily receive the attention they should. And we've seen sectors like the pharmaceutical sector, the chemical sector, the refractory sector, and of course, what we're here to talk about, the aluminium casting sector in India, where we are seeing a significant energy consumption, but definitely a need to push for greater innovation in this area. So within each sector that we have now for the aluminium casting units, we are looking to engage with MSME units within this sector. What we mean engage is to be a part of this study and to help us understand what the energy usage actually is over here. While there is some data theoretically about what the energy consumption in this sector is, we need to understand what is happening on the ground, how this changes year by year. So for us, the first part of the project, the most important part of the project, is for us to come to the MSME units and collect data on how you as an individual unit use your energy. So all the energy processes within the production will be mapped, and this entire process will come through once we conduct detailed energy audits. So this will help us create a baseline for what the energy consumption pattern is within the sector, within the cluster for your units. And once we can see this baseline, only then we can start analyzing how energy savings can be made for your particular unit, what energy efficiency measures can be taken. Now, this detailed energy audit is a key part of our project. And for this, we will be hiring an external energy auditing agency consisting of personnel having a lot of experience in energy auditing, particularly for MSME units in the aluminium casting sector, so that they can understand. Hello. So that they can understand, so that they have the experience and can help you provide the best recommendations customized to your particular unit, your particular cluster. So this is the first part of the project. And once we have the data collected, once we have done the analysis and we know what energy saving measures are, then we will take it one step further, when now we are going to conduct a proper techno-economic analysis to understand how these decarbonization technologies, whether they are feasible for MSME units, how feasible, and if they are not feasible, what is the gap that we need to start acting towards. What are these decarbonization technologies? We will be looking at three key themes here. The first is demand electrification technologies, by which I mean how you can you can utilize your thermal need through using equipment like electric furnaces or boilers. Your entire thermal requirement can directly be flipped over to an electrical side, which can then be utilized in a more efficient manner and decarbonized later on. The second theme we're going to look at are renewable energy technologies. Like you already know, solar power, wind power, as an example. These technologies provide electricity to you in clean, with low or almost no emissions. And what is also important to remember here is we are seeing in industries, especially given the industrial electricity tariff rates you have, renewables are not just cleaner, but they are often cheaper if you want to procure electricity as compared to the electrical grid. Lastly, we will also be looking at fuel switching technologies. So alternative fuels such as biomass or hydrogen, which can directly be replaced in your process heating equipment without having to make any changes in the process itself. So our study will check how feasible these kind of technologies are. I should also mention that this project is being funded by the MacArthur Foundation. It is a philanthropic organization, and the focus of this project, when we were talking about it, was on the MSME sector, because we have seen how the industrial sector as a whole is quite energy intensive, contributes a lot of emissions. But we do see that for the larger units, the larger industries, they already have the financial resources, they already have the technical know-how and the financing options to make these changes, make these savings themselves and adapt. Whereas these resources are not easily available to the MSME units. So this is why our focus has remained just on this part of the industry. So coming to so this was an overview of the project. Now coming to what it actually means for you itself. So as I've mentioned previously, a big part of the project for us is the initial data collection, for us to understand how in units you consume your energy, what fuels you use, how much does the energy cost you. So for all this to come in, and for us, we need the consent and the support of cluster associations and MSME units such as yourself to engage with us to be a part of the study, so that when we come later on to conduct the energy audits, we have units willing to take us through our process for us to understand how the situation is. Now, what are the benefits for the MSME units yourself? It's very important to understand that how important this detailed energy audit can be. Any manufacturing unit here willing to take part in the study will benefit, will be given the detailed energy audit. And this audit, which usually costs you, which is a bit expensive, this will be at no cost to the cluster association or the participating unit owners. This project is already funded, so that part is taken care of. Through this audit, you will first understand within your unit, how do the processes work? Are there any inefficiencies? Are there any leakages within your unit, or are you using your unit the energy flow in the optimum way possible? And if not, then you will receive recommendations from the energy auditing agencies on how you can make the changes to your unit, but I should say without affecting productivity. That is important. How you can make these measures, energy efficiency measures, how can they improve your production within your unit, and not just energy efficiency measures, but also the technology providers who can provide these solutions to you. And when we talk about recommendations, we also understand that the upfront costs are not, even if you see that there is a clear financial case for it, sometimes the upfront costs might not be there. So we do see the need to also provide what we call low cost or no cost recommendations, which are quick or simple measures that aluminium casting units such as yourself can implement. Might be just a small change in your production process, not necessarily changing any equipment, which might reduce your energy consumption and your fuel consumption. Lastly, I should also note what we will not be doing in this project, which is all this data that we will be collecting. This will not be shared publicly. The unit specific data that we will be collecting over the course of this project will not be shared publicly anywhere. We are purely a research organization. Our main motivation is just to collect the research, analyze it, and understand how things can become better. So if I take an example of, let's say, an aluminium casting cluster in Pune, tomorrow when we are going and talking to, when we are reporting our findings, or when we are talking to other agencies or policymakers, we will simply be talking about, okay, in Pune, this is the total amount of energy we are seeing consumed by aluminium casting sector. This is the approximate, this is the fuel share mix we see over here. This is how much it is costing the entire sector in Pune to procure their energy. No unit specific data, either your name, phone number, your production capacity, this kind of details will not be shared publicly. So these were the objectives of the project. Ultimately, what are the outcomes we hope to see? For the units, we hope that through the course of these energy audits, manufacturing units will get a better understanding of how they currently consume energy. Currently, how do they emit global greenhouse gases? How much does their energy cost them? And apart from this, providing the awareness, manufacturing units, you can also understand what are the best practices which are currently happening in the aluminium casting sector? What are the recommendations customized to you, which can help you in reducing your energy consumption, in reducing your fossil fuel consumption? How can this happen for you? And ultimately, if these recommendations are enacted, we hope that in the long term, through the adoption of energy efficiency measures or decarbonization measures, it will result in more profitability for the manufacturing units in the long term. Like I mentioned before, we will be for each unit which will be a part of the study, we will be providing a short report with all the energy efficiency recommendations for the short term, the midterm, and the long term, which would be the more significant investments. So with that, I think we can stop talking about our project itself. Now I hand over the mic to Mr. Rakesh Yecho, who is the expert in this field. Mr. Yecho, please, you can continue from here.
Thank you, Dhruv. First of all, I think I'm audible. You can continue with your screen. I think you can use your screen. At the outset, I would like to thank all the participants to be part of this webinar. And we have broadcasters, Mr. Jan, Mr. Lohia. Thank you very much for being a part of this program, sir. And we look forward towards learning from you also and sharing our experiences as well during the course of this activity. Well, there are energy audit, as was said earlier, it's basically a tool to identify the weak links in the production process. Now, weak links can be in the form of technology, obsolete technology. It can be in the form of inefficiencies in the utility and other systems. And upgradation of the energy efficient upgradation of this technology upgradation or improvement in the energy efficiency level of the equipments we are using, whether it's utility or any other system, can help overcome this limitation. First of all, energy audit is not a fault finding exercise. We'll not be there to find faults in the system. We are there to identify the weak links and sharing of experiences. I understand that die casters know their plants very well. They know their plants better than what we know. But we have an added edge in terms of inter-industry experience and inter-industry exposure, where we can share the good practices being adopted by different MSME units across the country in different utility systems and processes, which can be replicated in their units. So that advantage is there. And when we talk about, Mr. Dhruv talked about establishing a baseline of the energy consumption. When he says baseline, by baseline we not only mean the energy consumption of the yearly energy consumption or the monthly consumption. Baseline also means the energy efficiency of the individual equipments like the furnaces, energy efficiency of the pumps. We will be studying. So that establishment of that baseline will help us evolve specific recommendations for different systems, which can help the overall cost reduction in the MSME unit. Now, major focus areas we do have is basically the metal loss and excessive energy consumption are the two biggest concerns we do have in our die casting units, besides others. And these can be addressed if we, address the issues of the melting and the furnace process efficiency. Now, these can be, the efficiency can be because of various reasons, depending on the type of technology we are using or depending on the type of furnace we have, furnace design, what the type of burner we are using in the furnace, the type of air or the quantity of air or the quantity of fuel that we are firing into the furnace, and many other factors. So these are major areas which can lead to energy inefficiencies or metal loss or higher specific power consumption or specific fuel consumption in the furnace. So all these areas need to be addressed during the detailed energy audits. There are many other areas, which many of the MSMEs, I have worked with around 26 MSME clusters across India, pan-India. We are also doing a project right now in Bihar for the MSME sector. Now, my experience says that there is tremendous, saving. There are tremendous saving opportunities in MSME units, and this can go up to 15 to 20%, especially on the thermal front. Now, if this is addressed, I think the cost, the units, the MSME units will have a competitive edge in the compelling market scenarios today. Now, other areas which we'll be looking into is like I have pointed out some points here, like the contract demand, minimization of the contract demand. The load profile of the unit will be studied for 24 hours duration. And based on that load profile and the yearly consumption, the monthly demands you have, we'll be trying to analyze whether there's a possibility of contract demand optimization. PF improvement. Now, these days, most of the electricity, DESCOMs are having their, billing on the basis of kVH consumption, and power factor has a direct impact on the energy bills. So, improvement of the power factor can directly have a monetary, benefit to the units. Optimization of motor rating to meet the load requirements and installation of high efficiency motors. Now, as a thumb rule, we say in the industry that if the motor is loaded above 50% of its rated capacity, it's good, it's fine, no need to change it. But if the loading is lesser, and if there's a variable load in that particular motor, whether it is driving a pump, it is driving a blower, it is driving any other equipment, if the loading is less than 50%, we need to look into it. There is a scope for optimization. Optimization of the load unbalance. Now, in MSME units, we have often found that there is a load unbalance in the system. The three phases which are connecting are having variable loads, which can lead to higher losses in the system. And mechanical power transmission, we are using, by mechanical power transmission, I mean the belt drives we are using, or the POG belts, or the simple flat belts, or V belts. What is the efficiency of the belting system, or the gear drives we do have? What is the efficiency of this system? So there can be scope there. Harmonics, another important area of concern for the units today is the harmonics. Now, harmonics, as such, there is no penalization as far as harmonics is concerned from the grid as on date. But yes, this can lead to failures. This can lead to trippings if it is not addressed, or it is not controlled at the right time. Use of energy efficient axial fans. Now, fan efficiencies can be as low as 15 to 20% in many cases, if it is not properly designed, and if it is not properly, designed in terms of the pressure it is developing and the airflow it is delivering. And what is the type of control we have in the fan in terms of flow control? Are we having damper controls in the fan? What is the loss we are having in that damper control, whether it's a fan or a blower? That needs to be assessed. Next comes the pumping. Now, pumping is a major, area of concern, because the pumping efficiencies, today we have pumps which have efficiencies of around 80%. We can have an overall pump motor efficiency of around 67 to 70% operating efficiency. And in MSME units, in many MSME units, we found that the efficiency is as low as 35–40% for the pump motor set. And this is a huge, saving opportunity. Next slide, please. Now, leakages in the ducting systems. Now we have ducting, whether it is for the furnace, or whether it is for the blower ducting system. What are the leakages we have? Because if there's a leakage in the system, there's a loss, there's a direct loss, and this needs to be addressed. Now, this identification of these things has to be done during a detailed NPR with proper instrumentation. And we talk about air compressors. Now, air compressors is another area of focus in the die casting units. Now, compressor technology has changed over the years, and today we have air compressor which have specific power consumption of around 0.15 kilowatt per CFM. And most of the MSME units which I have visited over the past several years, they work on a specific power consumption of 0.21 kilowatt per CFM at around 7.5 bar. So technology has changed. So efficiency of air compressors can improve, and compressed air costing is one of the concern areas. Wasted, today we even have wasted recovery from compressed air compressors. These are technologies which are available. Atlas Copco or Endosol brand, they are providing wasted recovery options from the compressors. So this can be utilized. We talk about, the receivers of the air compressors which we have. We are using air receivers in the compressor. Whether this receiver is allowing the necessary buffing for the to allow the compressor to load unload properly. Capacity of the receiver, the sizing of the receiver, sizing of the pipelines, the sizing of the drain system for the air compressors is a very important aspect which will be catered during the energy audit. Similarly, I talk about cooling towers. Now, cooling tower technology today, Paharpur and other cooling tower suppliers are providing FRP fans, which were used to be aluminum castings earlier. Now, FRP is a good option. But besides that, there are many other areas which need to be addressed in the cooling towers, like the LG ratio. I don't think any of the MSME units today looks into the LG ratio of the cooling tower, which is basically liquid to gas ratio. The amount of liquid the cooling tower is from the cooling tower, and the amount of gas which is going up from the cooling tower. So LG ratio evaluation, even the suppliers do not provide the design data of the LG ratio of the cooling tower. Most of the suppliers, if not asked, they will not provide. So this area is untouched at many times. Lighting is another area which has some scope in the energy savings. Waste heat recovery, as Drew said, there is a potential of waste heat, and waste heat recovery the efficiency, even if the waste heat recovery systems are installed, like we have the recuperators installed or the APHs installed, the efficacy of these AHUs, of these waste heat recovery units needs to be evaluated, and there is tremendous potential for that. Another aspect is the performance monitoring, the continuous monitoring of the energy efficiency levels of the furnaces, energy efficiency levels of the other allied system. So monitoring and control, monitoring of the energy of the efficiency levels, online monitoring of the efficiency levels, and online evaluation and fault detection is another area which can be addressed. Radiation losses are another area of concern, which in case of furnaces is a critical area. And then we talked about, Drew spoke about the fuel conversion in terms of converting from fossil fuels to maybe grid. Of course, grid is also using fossil fuel for its generation. But if you think about renewables, or if you think about gas-based systems rather than conventional fuels, it can be a cleaner technology and much efficient technology. Next, please. Now, this is a case study in one of the units at Faridabad, and it is basically has a furnace, wet scrubber, the polarizer, acid machine, air compressors, and all. And the melting, as you know, is about 650 to 700 degrees centigrade. Next slide, please. And the energy cost of this particular unit was about 250 lakh rupees per annum. This is the annual energy cost, and with predominance of the furnace oil, because thermal energy constitutes a substantial portion of that. Next slide. And in terms of next, please. This is the monthly variation of the energy consumption. We had recorded this data on for the entire year. Next, please. And these are the areas which have been identified in this particular unit. Now, it takes care of the power factor. It takes care of voltage optimization for the single phase loads, installation of high efficiency lighting, contract demand reduction, energy monitoring, and the installation of VFDs and there is an oxygen optimization in the furnace. Now, recommendations will be specific to the unit, and one recommendation which is applicable in one unit may not be applicable to another unit. But yes, there we have to look into technologies, we have to look into energy efficiency measures which have higher application benefit, potential. So we will be looking into that also, because if one unit has one particular area which can lead to energy savings, maybe a similar type of recommendation or a similar type of technique or monitoring system can be installed in another die casting unit. So there can be a replication benefit, the replication potential, but recommendations will not be same for all the units. It has to be different depending on the type of unit, type of energy they are using, type of furnace they have, type of technology they have, and so on. Next, please. Now here, if you look at the energy efficiency improvement, there has been a reduction of around 19% in the energy cost. and 19% is a substantial quantity of substantial amount of reduction, which can always help the unit to achieve better. Next, please. This is another die casting unit, and it's a 600 ton production capacity, annual production capacity unit. It has electrical furnaces, and another, next slide, please. And the cost of the total cost of this particular energy, the production, the diesel cost was 360, and about 3.8 lakhs of energy usage in terms of the 33 TOE, and energy cost is about 29 lakhs per year. Next, please. And here, the saving potential of around 25% was identified, out of which around 15 to 20% was basically implemented and achieved in the particular unit. I can say that out of 10 recommendations which we normally suggest in a unit, all are not implemented because of various reasons. But our experience is about 50, even if 50 to 60% of the recommendations are implemented, it is quite substantial and it is an achievement. Now, another thing which I wanted to mention in this is that MSME sector, it works on past practices. Now, if a particular technology or a particular practice is being stick to for the last 10 years, say, we will continue with that based on the operators, based on the supervisors, comfort levels and his understanding of the operation. But there is a need to change. Equipment manufacturers have a very important role here, because equipment manufacturers keep on changing their technology, they keep on changing their product mix, they keep on improving the energy efficiency levels of their equipment, and that always helps. But besides that, within the plant, the operating practices, improvement in the operating practices can always help us improve the energy efficiency levels. I believe that as a conservative estimate, in the die casting sector, 15 to 20% reduction of energy is feasible, and it is possible in each of the units. And if full cooperation from the unit is provided, we assure you that it will be a win-win situation for the MSME units, for the die casters, and also for other stakeholders in this particular project. And with these words, I think I close it here. Any questions, you can always ask me, and we are there to share our views.
Yeah, thank you, sir. Ma'am, if there are any questions or something from the audience, yeah, you please let us know, ma'am.
We now open the session for questions. The participants, if you have some questions, please feel free to ask questions. And somebody is talking, but I think voice is not clear. Yeah, Mr. Manjunath, I think you are trying to. Yeah, there is no clarity in your voice. We are not able to understand what you are saying. You can also type your question in the chat box if there's some connectivity issue on your side.
I think there are some. There are some chats which I'm able to see. One is the regenerative burners also are new trends for gas-fired furnaces, which lead to energy savings of 15 to 20%. That's true. That's true. I agree with that. This is an option which is there, and they certainly are being used by the industry, and they can save energy. Improves insulation such as ceramic. Yes, insulation, as I said, the radiation loss is one of the concerns in most of the MSME units. and improvement in the insulation levels can always help. And in fact, they come with a payback period of less than 6 months in most of the cases. Waste heat or ladle preheating also. Yes, waste heat ladle preheating has been there, is being used by larger industries across India, and ladle preheating can always help us save energy, and it is being done. It is being used by large industries, but MSMEs, I wonder if most of the MSMEs may not be using such type of technology. Further, any effort to reduce goods casting percentage will reduce further melting requirements. Okay, yes, that's true. Because if the good casting quantity increases, certainly the specific energy consumption will go down. Because if the metal loss is less, metal loss in the scrap or metal loss during the process is reduced, and also the rejection rates in the casting is reduced, certainly the energy consumption will certainly reduce. Any possibility for energy efficiency in process which require purely fossil fuel? Look, it may not be possible for every unit to go in for a fuel changeover, because changeover of fuel will depend upon the availability of clean technologies clean fuels in that region. Number two, it will depend upon the costing more, because if we look into conventional fuels versus gas, it may be a clean technology, but if we look into the monetary terms, the cost of gas may be much higher. So the unit may not be in a position to change over because of the financial constraints. So within the existing system also, within the type of fuel they are using, we have to look into opportunities which can improve our energy efficiency level.
Ma'am, maybe we can just mention one or two things more about the project if anyone is interested. So we do hope that once the units are finalized, that in the months of end of May or maybe June, maybe July, that the energy auditing process can go through for the units in the area.
Yes. I hope the participants have got this understanding that ALUCAST and CSTEP, they have joined hands together, and we are going to conduct energy audit for the MSME units in the die casting industry across the country, so that this study and this analysis of energy consumption can be carried out in these MSME units. And as Mr. Rakesh has also rightly said, and Mr. Rajiv has also told in their presentation, that the recommendations will be based on the energy consumption levels of the particular MSME unit. So the next step that we are going to now do is we are going to now identify the MSME units who would be interested in participating in this project. And it has been clearly mentioned that this project is not going to incur any cost for the MSME unit. The energy audit would be conducted free of charge for the MSME units. So we request the participating MSME units in this webinar to get in touch with the ALUCAST office and communicate your interest in participating in this project, so that, as Mr. Rajiv has just said, that the energy audits can begin towards the end of the month of May, right, Rajiv?
May, June.
Yes.
Yeah, possibly.
Yes. So once the MSME units communicate their interest to us, then accordingly we can plan our schedule for the energy audits.
That's right.
Yes. A few more messages in the chat box.
Oh yeah, we should also mention, ma'am, that for this project we are looking at 2 locations anywhere in India, and within each location we are looking for at least a couple of units so that it can constitute a cluster.
Yes.
So Yeah, at least 5, maybe 10 MSME units in a single location. That is important for us per location, I should add.
Yes, yes. I hope Mr. Rajiv and Mr. Rakesh, you have gone through all the chat messages.
Yeah, I think so.
Yeah. There was a sort of a question from Mr. Manjuna that is there any case study on the cost reduction in industries already using electric furnaces?
We don't have it right now, but it can be shared with it if required.
Okay.
Let's share the case. Well, one of the observations regarding the diesel generator using during power cuts. Well, use of DG sets, the only alternate. I don't think we have a visible alternate here, because even if you have solar PV, that does not work when the power goes off, because these days the solar PV systems are grid interactive system, and these systems work only when there is a frequency, when there is a grid frequency, and they are integrated with the LT supply. I don't think there's a option there, except for if we have some gas-based systems. See, many units I have seen in Bangalore and all, they are using CHPs now. Now, because the availability in Bangalore, near Bangalore and all that, we have gas availability. Many units are now coming up with combined heat and power plants. Now that meets their heat load requirements as well as their the power requirements. So that could be an option for some of the units, but it has to be looked into. The ceramic fiber modules are much applicable for electric furnace also. True, that's right. Recommended kilowatt for holding. Now it will depend upon the size of the holding furnace and what is the quantity of material we do have in it. The kilowatt would be decided on that. Is there any alternate option for ladle preheating to reduce power? Now the options available is that we have to have the conventional burners, energy efficient burners for ladle preheating. Many units are these days using the same technology. I think this is from Vishal. We are talking 18 to 20 mid-size units for connector. Okay.
Yes, Mr. Supreet Jain, any question from your side? Mr. Supreet, are you there? Lohia, sir, any question from your side?
Nothing else.
Lohia, साहब नहीं question पूछेंगे. We will ask questions from Mr. Lohia once we come to the audit. We will ask for suggestions and questions from him.
I don't have any question as such. In fact, I is excited to have this project going on, because for die casting industry, energy consumption and control of the cost on energy is going to be really a big challenge.
True, that's right, sir.
Yeah, particularly because now the casting sizes are going to go up with e-vehicles coming in the production range, and the casting requirement will be quite different, with bigger sizes of casting to be manufactured, and that will be a challenge.
The challenge, it has, let me share with you, sir. We are doing a project for railway workshops and across the country on behalf of Bureau of Energy Efficiency. Now there also the changeover to high-speed vehicles has changed the casting process. Now the whole technology is changing. You are right, because of the EV vehicles coming in, it is going to be a big challenge.
In fact, I must appreciate the details in which you have gone of the points of energy consumption, including pumps and motors and that type of thing, which or even for that matter, air compressor or air consumption, because these are the things which are hidden things latent in the nature, and many times we don't understand the implication of such things on the energy consumption, on the energy costs.
Right, sir.
Ma'am, there's a question about emailing our nominations as well.
Yes,
so yeah.
Yeah, I have responded. I
Okay.
request the participants to get in touch with with ALUCAST, and the ALUCAST would forward these nominations to CSTEP. This is the way we are going to go about it.
Okay.
Yes, yes. And like ALUCAST will be in loop for this entire project.
Okay. Yeah, definitely.
So the participants, I think there was a question from Mr. Manjunath. So I would like to communicate this to all the participants and all the representatives of the die casting industries who are a part of this webinar, that your nominations should come to the ALUCAST office. We are going to circulate a feedback form to all of you, maybe today by evening or tomorrow. And we are going to ask you that if you are interested to be a part of this project, you have to communicate your consent to us through the feedback form that we send to you. And then these nominations would be grouped and then they would be forwarded to CSTEP.
From our side, I think I should just reiterate once that we are looking for MSME units for this project. That is our focus. Yeah, that's it.
So no more questions from the audience. Is that so? Anything more from the audience, from the participants?
Only thing, madam, what I feel is at least one case in die casting should be studied in depth and the results shown as quick as possible, because that will motivate all others to go for joining the project.
Yes. Yes, this is a good suggestion from Lohia sir, that we begin with one MSME unit. We have an audit for them, come up with recommendations, and probably that will help to motivate the other die casting MSME units to come forward and become a part of this project. Does it sound good, Mr. Rakesh and Mr. Rajiv?
Yeah, we'll just, I need to speak to the rest of the team regarding this, but yeah, we'll communicate with this back to you.
Yes, 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 yes. Okay, then with the permission of the participants, as well as Mr. Rajiv and Mr. Rakesh, Mr. Krishnan, should we close today's session?
Yeah, from my side, I think that's all we have to say. Mr. Rakesh, if you have anything else.
That's fine.
Yeah, I think that like some of the participants have expressed their concern, like, can this be done to reduce the energy consumption and all? So obviously, I think the CSTEP team and the energy audit team will obviously be able to give recommendations more appropriately and more aptly once the team comes to the MSME unit and studies the energy consumption levels at the MSME unit, and probably the recommendations can be more relevantly made to that specific MSME unit, right?
Yeah, that's right.
Yeah. This probably a general discussion on reducing energy levels, probably because we need to go a step further through this project, right? It is not only a, yeah.
I would like to add here, see, nobody has a golden stick in his hand that we have to analyze the thing, we have to measure the performance of the systems and then suggest. So energy audit, as I said, is a tool, wherein we evaluate the efficiency, existing efficiency of the system. No energy audit, as I said in the earlier presentation, that the unit owners and the people who are working in the unit are much more efficient and they know their plant much better than what we know. Only because we have, instrumentation support, we have an inter and intra-industry exposure of the things. We are in a slightly better position to tell them that these are the weak links, not the faults. These are the weak links in the system where you can improve.
Yes.
So once the audits are done, I think more specific recommendations which involve no or small investments, which involve some investments, would be suggested in the reports.
Yes. Yes, I think, yes. So the recommendations will be more specific and more aligned with the business unit once the audit has been done, once the existing processes, the existing energy consumption is being studied, is being analyzed, and then probably more aligned recommendations can be made to the specific business unit. And that is why we request all of you to become a part of this project and benefit from this project, because as Lohia sir has rightly pointed out that the cost of energy is going up, and this is a major concern for all the die casters, all the die casting industries. And that is why I think this is something, a very good initiative, and we should all benefit from this initiative. So we request all of you to please register your interest in this project, become a part of this project, so that we are able to help you for the good of the industry, for the good of the MSME business units, because Mr. Rakesh has rightly pointed out that bigger industries, bigger players do have mechanisms, do have processes set in place, but the MSME units do face challenges on certain fronts. So this initiative, this project will probably be a good help to the MSME units in the die casting industry, and so the MSME units should take interest in this project, become a part of this project, and benefit from this initiative. Okay, with this, I think we close for the day, and this is going to be a project that it's going to go on for the next 5 to 6 months, and I think it is really going to benefit the MSME units in the die casting fraternity. So we look forward to nominations from all the MSME units across the country. Once the nominations come to us, we can group them into clusters, and probably we can start with the energy audits. Thank you for joining all the participants in this webinar, and I look forward to receiving communication from all of you very soon through the feedback form that we are going to send to all of you, maybe by today evening or maybe latest by tomorrow morning. Thank you so much for joining. And
Thank you.
And thank you, Mr. Krishnan. Thank you, Mr. Rajiv. Thank you, Mr. Rakesh, for joining us for this webinar and for sharing insights into this project. Thank you so much.
Thank you, ma'am.